Here's a video recording of the RRT dynamic planner. In this case, we have a time step of 0.1 seconds, so basically 10 hertz. Velocity is at 1 meters per second. Here the x-axis is 10 meters by 10 meters y, where this is basically a top-down bird's eye view of the world of the plane, as the robot wants to go from 1,1, shown in green, to 7,7, shown in red. And basically we're going to run this and see how the tree expands as the code runs. So the tree expands like this. It doesn't run super fast, but the way I'm plotting is just by running this function called draw now, and I'm doing it every 10th iteration just so it's faster. It will end when the tree has a point that's within some distance of the skull, and that distance needs to be a 0.25 meters Euclidean distance. We notice this thing where we keep getting all these circles, which seems pretty random. I think there might be something wrong with the code. After all, there's a lot of debugging to do still. But I think the reason for circles could be that the car just sees that as the closest way to get to points, I guess. But that wouldn't make sense because in some cases, like, I'm not sure. But we'll see what happens. So as it goes, it should be getting to this point. Hopefully it doesn't get stuck where the closest point is always the same point and it always wants to go the same distance, because that would be bad. It'd be in some type of infinite loop, and I think that's kind of what's happening oftentimes with these circles, which means that we may need to change this Euclidean distance function to either weight the orientations more or weight the orientations less. I believe that we might want to weight the orientations right now we're just taking the Euclidean distance of the radians. So if we wanted, oh, it's almost there. And then once it does get there, we should be able to see like a red line of how the path looks like. So I mean, we're going up to 10,000 iterations here, which is not a small number. So we'll just see what happens. Let's see. Okay, still running. Still running, almost there, I guess. It just needs to see some random configuration that happens to be in there, which is actually kind of hard to get. Jeez. Okay. So those take a while, because the thing is, like, if you think about how many points there are, this is an area of 100 square meters, and we're talking about a distance that's within 0.25 meters, 0.25 Euclidean distance, which could even be like, I mean, 0.25 Euclidean distance could be like 0.25 by 0.25, which is that divided by 100 means your probability is 0.0625% chance, which is entirely why it takes so long. Jeez. Okay, so I think it did reach there. Okay, so cool. We have that point now. It took a while, but realistically when we run it doesn't take that long just because it's plotting super slowly. But now when we press continue, it should show the red line, hopefully, and there's the red trajectory. So this is a trajectory which looks pretty feasible for a car that would eventually end up there. And that's basically what the code does. Cool.